Thanks for joining us today. So we're going to go over just some basics on wireless microphones and what TOA can provide you for wireless solutions. So this is just a small demonstration of some of our products that are available, ranging from entry-level products to more higher-end specific products. We'll go into a little bit more detail. So just a quick rundown of what we're covering. What is a wireless microphone? How does a wireless mic work? Microphones, condenser versus dynamic, diversity versus true diversity, terminology, frequency bands, applications, and our lineup. So obviously it's a wireless microphone. There's no physical connection between the wireless or the microphone and the receiver. It has a small battery, powered radio transmitter. Lavalier microphones or lapel mics are clipped to lapel, tie, whatever it may be, and connect to a belt pack. From there, the transmitter sends a signal to the radio or receiver nearby. The receiver will connect to a mixer or other equipment like that. Just a few examples of what we offer on the bottom as far as handheld belt pack and receivers go. The wireless microphone converts sound into radio signals using a transducer. The body of the microphone is then sent, the body of the microphone which are sent from a transmitter to a receiver, which sends it to the sound system. Whereas a wired microphone converts sound into electricity and sends it down a cable, wireless microphones use radio frequencies to transmit the sound. Dynamic and condenser describe the different operating principles of a microphone. By operating principle, we mean the type of transducer inside the microphone. So basically how the microphone is going to interpret the sound in the area or the room and then transmit it into an electrical signal to get back to where it needs to be. They're the two commonly used types of microphones. We'll go over that in a little bit more detail. Dynamic mics are very good sound quality, very good at handling high levels. The authority typically used for singing or larger presentations. Dynamic mics are great because they can take a lot of rough handling as well as extreme temperature, humidity, and moisture. Pretty common dynamic mics are used for music applications, concerts, and different venues like that. So dynamic microphones have a simple design, a diaphragm and a voice coil, and a magnet. The dynamic mic, aka moving coil, microphones are probably easy to understand because they work just like a loudspeaker. The diaphragm, which is the cone, moves back and forth, which is connected to the coil of wire past the magnet, and doing that creates the signal that goes back to the mixer, in this case to the transducer to the receiver. The sound wave strikes the diaphragm, which causes it to vibrate back and forth. The voice coil, which is a small bit of wire attached to the back of the diaphragm. Field created by a small magnetic sound. Small magnet surrounds the voice coil. When moving the voice coil, the magnetic field generates a signal which is corresponding to the sound. Condenser mics are preferred for their very uniform frequency response and ability to respond with clarity and transient sound. They are lighter. They're not lower mass of the diaphragm permits them to have a higher frequency response. They're very good at picking up low frequencies. The result is a natural sound, a clearer sound with excellent transparency and detail. They are more sensitive than dynamic mics as they pick up more high and low frequencies. Typically, these are microphones that are found in recording situations as well as situations where the source is further back from the microphone itself. So the condenser or capacitor microphone is a lightweight membrane and a fixed plate that acts as opposite sides of the capacitor. Sound pressure against the thin pole of the film causes it to move. When the diaphragm of a condenser mic vibrates, it alters the space between the diaphragm and the back plate, which creates the electric signal. Sort of very similar to the dynamic principle, where it still is a moving, physical moving piece of the microphone to create the sound. So just to sum it up quickly, high FPL handling for dynamic mics, durability of use, they're inexpensive and they are not affected by temperatures. Condensers are sensitive, they're fragile. Lower handling noise, which is great for, by lower handling noise we mean nursing a microphone back into a clip or adjusting a jacket with a lapel. There's going to be less of that bumping sound you'd hear when someone bumps the mic back into a stand. They do require phantom power, which is how the condenser actually returns back to its original state. A little bit more pricey just because of the output, and they can be made quite small. So we're going to look into the receiver now, the receiver being the tuner that goes the business end of it on the rack side. The number of channels in a receiver permit multiple systems and multiple microphones to be used at the same time. With more channels, you have more options for connection. A good example of this is house of worship or entertainment, somewhere you need multiple microphones in one place, aka lead singer, backup singers, bassist, guitarist, or drummer. More options choose the right frequency. Additionally, with channels, the more channels you can move away from interfering channels. So with receivers, there's different types of, I guess, methods you want to say on how they will actually pick up the signal that the microphone is transmitting to it. So a diversity receiver is it's an entry-level system. The receiver may have one or two antennas which are physically connected to each other. The system has one tuner connected directly to the antenna. They're prone to multicasting dropout. Just so you know, multicasting is the transmission of audio over wireless or a signal, and no feature to help improve the sound of the situation. So with that, the purpose of two microphones on this tuner would just be to give a bit better pickup pattern, but you're not getting much advantage out of it because both microphones are feeding the one tuner. So in a space diversity system, it's a mid-level system, two antennas which are not connected and spaced apart. One receiver is present. The circuit monitors the RF level of the antennas. Once it's low, once it starts to decrease, it will switch to the other antenna. These are really reliable in large spaces, so gymnasiums, larger conference rooms, and theatrical venues, places where you're going to have a lot of mic travel across an open space. True diversity systems are the more or less pinnacle of the wireless diversity system. It takes it to the next level. There are two antennas connected to two tuners, and the circuit will then monitor both and switch back and forth when the tuner is receiving a lower signal. The reason why this is better is there's going to be less chances for a dropout because the tuner will then accept the signal and pass it on, and then that signal's already been received. You're not interfering with the signal. At this point, you're just interfering. You're causing a switch between the audio as opposed to the RF. So this is just going to cover the types of antennas that you can expect to see on wireless microphones. Pretty straightforward. External antenna. They can be built onto the tuner itself. Some cheaper microphones will have the tuners built in. TOA doesn't make any of those. We prefer to have the antennas mounted on the back or front. Some are removable, some are fixed. Higher end systems are removable, and the reason for that I'll get to. The lower end systems are fixed. The purpose of using a removable external antenna is so that if you install a microphone or a wireless receiver in a rack, you're not limited to where that receiver would be. You can put the antennas where the microphones are present. The antennas should have peaking circuits to compensate cable loss. That's an important feature. Antenna feed wire is another big area that commonly is overlooked. The feed wire is what connects your remote antenna to the actual receiver. You got to make, whether you're using TOA or any other product, you need to double check to make sure you're using the specified cable. TOA recommends RG6 or RG11 coax for long runs. RG6 will get you 35 meters, RG11 will get you 50. it's important that those specific types of cables are used for these applications, as you'll run into impedance issues and dropouts. So we'll cover polar pattern really quickly. First one here is cardioid, bidirectional, supercardioid, omni, shotgun, and hypercardioid. Now this may sound really overwhelming at first, but they're all sort of the same thing. They're examples of pickup patterns, but also examples of different microphone types. So omnidirectional is what it sounds like is omni. It picks up in a 360-degree radius, ideal for sound stages and natural recording environments. Lavalier mics are commonly omnidirectional because there is some movement with them. They're not necessarily great for live performances, as an Omni mic's going to pick up any other noise around it and then feed that back. So number one reason for feedback when using when using a wireless microphone is you're using an omnidirectional when you should use a different type. The Cardioid Uni-Directional. As you can see by the polar pattern on that microphone, it picks up in a more front-focused pattern, catches the sound in the front while rejecting the rear. It isolates ambient sound, which in a lot of situations are not wanted. Perfect example would be any noise behind the microphone, as in a backup singer singing in front of a guitarist. You're going to pick up whatever's happening in front of the guitarist, and this is why the cardioid is live performances, from small-time karaoke to the largest concerts, you're going to find this type of microphone. Positioning has a significant effect on the sound coloration of the source. Yeah, exact positioning is required when using a cardioid mic. The biggest problem people run into, and a lot of performers run into when using a cardioid mic, is they will cup the mic, which is right up by the top, and you're holding it almost around the grill of it. That's a really popular way to hold a microphone, but is completely incorrect. Next is, well, these patterns also apply to wireless microphones. The only real difference between the wireless and wired is the disconnect of the cable. The pickup patterns would be the same. A simple way to explain it is if you have one person talking in front of the mic and one at 90, your distance dB rule comes into play. So when distance is doubled, you lose 6 dB. So the person at 90 degrees will be 6 dB quieter than the person directly in front of it, which is really useful when singing and presenting on a conference or even a live concert. So we're going to go over signal transmission. This is how the sound goes from the microphone to the receiver. Analog, or UHF, is a sense for ultra-high frequency. What this is a method that like I said, the microphone will transmit from the mic to the receiver. The digital wireless systems are a little bit different. They work by converting acoustic sounds into digital bit stream at the transmitter, and the signal's converted to audio on the receiver. Digital wireless is becoming much more popular now, simply because it's a more reliable and dedicated connection, but you have to consider when purchasing a digital microphone, the digital to audio converter. Cheaper microphones are going to have cheaper digital to audio converters, and then you're going to lose sound quality, which brings us to this. Although there are many variables that can come into play, excuse the typo, generally speaking though, digital systems have better audio from dynamic range. The main reason is analog systems need to compress the dynamic range of the audio before sending it down the transmitter. They do this by using a compander, and once the signal is uncompressed. Sort of like taking a recording, putting it online, and then downloading it on YouTube, and then downloading it from YouTube. You're getting it uncompressed and then decompressed, or compressed and decompressed quality. You're losing bits and pieces of the true form. Latency is another issue. So analog, which as opposed to the sound quality, has zero latency. It's a direct connection. There is no conversion from analog to digital. Digital systems can vary, but it all depends on the processing power of the microphone itself. Small amounts of latency are tolerable just because of reverberation in the room and echo. RF performance is important as well because that is key to any wireless system, is how well your RF connects from your transmitter to your receiver, RF standing for radio frequency. Both UHF and digital operate on the UHF band of 470 to 865. Digital systems are more spectrally efficient in this space. With that being, some digital systems allow up to twice as many compatible microphones in the same RF footprint. Just means that there's a wider range of frequencies in the allotted range that microphone will be giving. UHF can handle more systems than digital in the 2.4 gigahertz range, which is new. The RF interference can happen in either analog or digital systems, so be prepared to make frequency adjustments as necessary. So security and encryption is something that also has made its way into digital microphones, wireless microphones, specifically in the digital wireless, wireless microphones in the 2.4 gigahertz microphones. They share the same encryption as Wi-Fi using the AES 256 protocol. It's important that some microphones are using this, some are not. It all depends on the variety that you're shopping. Really important thing to consider is frequency band when purchasing. So as of October 2018, North American companies are no longer permitted to sell microphones in the EF or G band, which is the 600 to 668 megahertz band. These frequencies have been reclaimed by the FCC and will be repurposed. Other bands, being H and M, are just outside of that, and they still will work within the even though it's in the 600 megahertz range, it still will work neighboring beside the restricted band. And TOA, just to go back on that, TOA does have new products in both. All of our 5000 series, as well as our S410, come in the H and the N band, so we are keeping up to snuff on the changing wireless environment. So just a typical rundown of how you use a microphone with an amplifier and a specific application. You can see here, this is a small classroom. You'd have a wireless receiver at the front of the room, paired with a handheld microphone. From there, it would feed a power amplifier and then to the speakers. Pretty basic system. Larger system like a gymnasium, you may not have the ability to have a wireless tuner out on a desk or out in line of sight with your microphone that's transmitting the sound. So in this situation, we would use the YW4500. These are the remote antennas. They'd be placed opposite each other or positioned slightly opposite each other in a large space like a gymnasium and connected with the RG6 or RG11 cable, depending on the distance you have to run. So in the diagram on the right, the wireless microphone will connect the antennas, which run back to the tuner, which is the WT5805, to the power amplifier and out to the speaker. And then this is basically the same system, but expanding into a larger application. In an auditorium, you can have multiple wireless microphone, or you have multiple wireless antennas that can run back to a receiver. What this one shows, if you look at the top left, this theater has a small studio beside it. So what that image is showing is that the microphone's installed in the main stage area, but because there is an antenna connected to the distribution unit, which is the WD4800. Sorry, that should be 5800. The wireless microphone in that main space can be used in the studio theater, so that it will actually send the signal down the line through the antenna, the distribution unit, and back to the receiver, and then back to the mixer, to the amp. Other sources connect to the mixer, and then sends it all out to the speaker. It's all sort of the same principle. It just scales with the size of the application. And again, another larger explanation. This was different in the sense where it has 3 tuners, so if you needed to have 3 different microphones operating at the same time, you would need 1 tuner per microphone. In this situation, we've used the WT5800 as an option. This is outlining how TOA's 5000 series microphone system, it can interlink receivers. So if it didn't have this ability, you would need a pair of antennas for each wireless receiver. But because you can link these units together, you're able to do 2 antennas that will serve to feed each tuner with the wireless signal. Just note with the 5000 series, you can link up to 3 tuners before you have to add more antennas. Just going into a bit more detail about what you saw, the 58, the WS5225, that's our entry-level 5000 series wireless microphone and receiver. That is the condenser version. The WS5265 is the kit that includes the dynamic version, and then the 5325 is the headset or lavalier version. So these are just the different product codes with what you'd order in a kit. So you get the microphone, the receiver, and in the 5325 case, either a lav mic with an Omni or Uni-Directional, lavalier, or a headset mic. And then this goes a bit more into detail of actual product numbers of what you need to do to order this. If you have any questions or need anything, need to order this product or want more information, you can just reach out to our customer service department or the technical department. We can give you more details. This shows you the lavalier type of microphone. As you can see, the 5000 series has a locking collar on it. Now this is crucial as microphones are commonly, the lavalier microphones commonly mounted on a lapel or a shirt. Movement can cause it to unplug. That prevents that from happening. Same with the other microphone on the left. That's from a S4 series microphone system. And then there's the assist earphone. With the 5000 series, we also offer a wireless receiver, a portable receiver. So that would be used in situations where hearing assist would be required in a space. A bit more information regarding some of the accessories. The WD5800, that's a wireless antenna distributor. So what that lets you do is connect 2 wireless antennas, the YW4500, to this unit, and then it distributes out to 4 different outputs. So you theoretically could have up to 16 receivers fed by 2 antennas using the WD5800. With the WD5800, you also get power supply outputs for each of the tuners, or the tuners, which is important because then if you didn't have a ton of rack space and power outlets, you could power all of your receivers. Sorry, I didn't mean to say tuners, I meant to say receivers. So the actual receivers, you could power all of them from the WD5800. The WTU4800 is it's a tuner unit. So we have see if I can find an example of it real quick. I don't think we have a picture of it in there, but we do have an option. We do have a series of the WT4820. What that is it's sort of like a bare bones version of one of our wireless systems. You can swap out tuner cards, so you can get expand it and modify it as needed, and then the battery charger for the body packs and handheld mics. Into our more pro line of microphones, we have the Trantec series, the 5.3. HD is the handheld, L is the lavalier. Work on the same principles. You just have a bit more features as far as display, functionality, and operation. And then on our more affordable side, there's the S410 UHF microphone series. This is new. This isn't offered in the M-band frequency only. This was going to comply with the FCC changes that have been put in place. It's our newest mic line, very good dedicated signal, and really affordable price. This also has relocated antennas, so those antennas on the back can be moved, and you can use the YW4800. It's not just the 5000 series that those wide antennas work for. So we do have a digital wireless microphone coming soon in 2019. It does operate on the 2.4 gigahertz band. We're doing quite a bit of testing with it to make sure that we have. One of the common questions is 2.4 is a very busy frequency as it's shared with Wi-Fi. A lot of manufacturers are going this route. Why use 2.4 when there's already a lot of traffic? Well, the reason being is 2.4 is 2.4 gigahertz as opposed to 600 megahertz. It's a much, much stronger frequency. You're getting a much more improved range. Line of sight isn't as imperative, and the digital connection is unparalleled to anything an analog UHF can compare to. As well, the encryption is there as well.